one we have one last week where the telescope might be used, but at the same time, people are going to be staying at the telescope to check out the electronics, because on April Fool's Day, the observing stops for the season while the new robotic system is installed. And the idea was originally that we do it over the summer, except they realized they need to be able to test it by pointing the telescope at things more than clouds. So this is the dawn system, and one presumes that it will move quietly because as quiet flows the dawn. Never mind. I don't know how many people know their Russian poetry. Never mind. But this is the system that we have, got a wonderful grant from the Lord Trust Foundation. It runs about $600,000 to install it. But when it is installed, you will be able to use the telescope remotely from anywhere. Not just that, oh, I can, log on to the telescope and take images. We can do that now. But that the robotic system will check the weather, figure out that it's not raining, open it, start the pumps, start all of the machinery that makes the telescope go. And our telescope has a ridiculous amount of such machinery for a 1.8 meter telescope, because it was the test bed. It was the one where they tried out all of these things before they built the large binocular telescope and other things. So, for instance, the entire telescope floats on oil. But that oil has to be pressurized, so you have to have the oil pumps. And in fact, 2 oil pumps in case one of them goes down, which has been known to happen. And the oil has to be cooled to the right temperature. There is coolant that goes through the mirror that is computer controlled so that the mirror is exactly the same temperature as the air above the mirror, which changes during the night, of course. There are fans that pull the hot air out of the dome, so that all of this building up to the fact that for a telescope its size, it does a pretty darn good job of having very sharp seeing. And this not only gives you the ability to take sharp images that are, limited only by the optics of the telescope, but it also allows you to make more precise photometry, because the light is concentrated on a fewer number of pixels, which means that the signal to noise is greater on those pixels. So all in all, it's a wonderful thing, but as anyone who's used the telescope can tell you, it takes half an hour to get it going at night and then another half an hour to shut it down. What makes us think, I think I mentioned this the last time, but what makes us think that this automated system is actually going to work? What confidence do we have in these people? It turns out they've done a number of telescopes already, so that's a great confidence booster. But more than that, the company's actual business is to automate breweries in the Czech Republic. And so that they're going to be sure to have things working right, because that's practically a religion there. And the guy who invented the automated brewery system happened to be an avid amateur astronomer. So he figured out, oh, we could use this also for telescopes. I noticed that we've had a few more people join since we were last here. So before we go into the program for the day, I'll ask Tom, we've been going around asking people, where are you going to be for the eclipse?
Hi, Tom Cole, a little north of Philadelphia, and I hope to be on my front lawn taking pictures of the eclipse on that day.
Which is where? In Philadelphia?
A little north of Philadelphia, yes.
So you won't be in totality, but you'll get some nice. Okay. No. And Michael Mack. Oh, sorry.
I'm going to be near Bloomington, Indiana.
Which is where I'll be.
Yeah, I'll be I think I have a little site there, Lake Lemon.
Ah.
Or Lemon Lake.
Okay. And the other Michael Butler. And looks like your connection isn't stable enough to let us know. Okay. Well, what I would love to do, since we're being recorded, I have to be sure I do this introduction right. It is my incredible pleasure to introduce somebody who I've wanted to rope into this for a long time, a very old friend of mine, Brad Schaefer. He's so old that he's retired. He's a retired astronomer at Louisiana State University who has done an incredible number of really clever and wonderful and fun bits of astronomy. And the information is especially, the emphasis is especially on the fun part. We met first when we were both in the science fiction club at MIT a zillion years ago, and then got to know each other much better when I was a postdoc at MIT and he was a grad student. And I'm going to start there. Brad, can you describe how the research that you were doing for your thesis led to you becoming something of an expert about using the human eye as an astronomical detector?
Hey, actually, it was not gotten in through my thesis work, which were on gamma ray bursts. But I just started reading papers on astrohistory and realizing, hey, that's all wrong. I can do better than that on a variety of topics. And what I started fascinating on is what you can see with the human eye, just looking up there. What are the limitations on it? And it turns out, kind of through the literature, people had fairly cruddy versions for various particular questions. And so a little bit of my specialty on that is going out and actually making real observations, huge volumes of systematic observations with multiple people, me, Martha, doing anatomy experiments on my wife, so you actually go off and get real ground truth as to what's visible.
One of the things that I do remember was connected to your thesis was that you were looking for optical counterparts to gamma ray bursts and wondering, could those have been seen by human beings?
But probably the answer is no, but I was trying to find such things. What's relevant for today, actually, is the visibility of the moon. So I've done a lot on the visibility of the moon. I've spent about a man-year of my life doing by far and away the best astronomy for visibility of, in particular, the crescent moon. And that's kind of important for determining the date of the Crucifixion and the date of Easter and things like that.
How does that work?
For today in particular, the date of Easter, today is the day of the full moon, which is why we're collected here together. And today is the day of the full moon, as I could see when I went out a few hours ago and saw the penumbrally eclipsed moon. So it's as full as you could get, and that's today. Okay, so today's moon is important for Easter because Easter, at least in the Catholic Church, is defined as being the first Sunday after the first full moon after the spring equinox. Well, at least the spring equinox in the north. In the south, it's, well, the vernal equinox, fine. And so the equinox was March 19th, a few days ago. The next full moon is today. And so next Sunday is going to be Easter. There we go.
That is almost the way that it's defined. That's the way it was defined until the reform of the Gregorian calendar, when you have to worry about what, it was a full moon on Monday, but what if it was a full moon on a Sunday, and which part of the world do you do it? And so there is a formula that attempts to recreate that. But yes, that was it was the first Sunday after Passover, and Passover was the full moon of the first month of the year.
Right. And you pointed out that there are little loose edges in that definition I gave. Here's one which has broad relevance and a little bit worrisome for ecumenical things. And that is, for example, should you use the Julian calendar or the Gregorian calendar? And you get different answers if you do. Usually they differ by about a month. So in the Catholic Church, the Easter is next Sunday, March 31st. But in the Orthodox Church, uses the Julian calendar, and their Easter is going to be on May 5th. Where'd that come from? Most people haven't heard about that. But there are other little dodges in there, which are technical things you kind of alluded to. You have which particular day you're talking about. And you can have a full moon occurring before the equinox, but on the same day. How do you count that? Well, so what the Catholic Church has done is they've quantized everything into units of days, and they're dealing with local days so that you don't have to worry about which time zone the day occurs in. And even more, they've worked out a stylized lunar orbit for determining when the full moon is.
So how can this be used to date the crucifixion? I imagine it must be a simple thing. You know that it happened around the time of Passover, and you know it happened on a Friday. Therefore, you work out the position of the moon, and you determine when was there a Friday Passover? Is that right?
Yeah, well, that was a task I gave myself long ago, and it's a task everyone has done before, or many people have done before, even starting back from Isaac Newton. So it's an astronomical question, actually. So the question of dating the original crucifix comes down to, you're looking for a Friday, you can argue about that, on either the 14th or the 15th of the month, and you can argue about that, of the Passover month of Nisan, and there's actually ambiguities on intercalations there. And it has to be during the years of roughly 27, or not exactly, 27 to 36 AD, which is when Pilate was reigning in Jerusalem. And so there's a lot of little loose edges in here. Here's one that probably no one in this chat has heard of before. Guy, actually you might have. You immediately started calling this a Friday. Well, that's why we call it Good Friday. Okay, fair enough. But there's actually a fairly strong set of traditions among branches of Christianity, I'll call that, where the crucifixion happens on a Wednesday. And there are yet other people who are rivals of them, and they go back and forth, where it's Good Thursday, not Good Friday. And it turns out the actual biblical basis for this is equally good. From the Bible, what it says, you can equally call it a Good Friday or a Good Wednesday or a Good Thursday. And Guy, way back when, you gave what might be the best answer was, you're going by tradition. And tradition has it being a Good Friday. And that overcomes small ambiguities in the text you get from the Bible. And that's adequate.
Because even the text in the Bible says it's basically the day before a holy day. And it can be the Sabbath. Most people take it to be the Sabbath, hence it must be a Friday. But what if the holy day they were talking about was actually Passover?
Exactly. Yeah. And so it's ambiguous. There are two types of holy days. And which was the Bible referring to? Well, we don't know. Nevertheless, your old answer of tradition, is that what you do on Fiddler on the Roof? So Good Friday. So we're seeking a Friday, which is the 14th or the 15th of Nisan in the year 27 to 36 AD. And you can narrow things down a little bit because Jesus' ministry happened a few years into Pilate. So you might look for various reasons, you might look to 30 to 33 AD as being better years. But this is a basic it's an astronomical question. And even Isaac Newton has gone back and tried looking at this. And where I come in is that the question, determining the dates of the 14th or 15th of the Jewish lunar month of Nisan, and determining which month is Nisan, That's an astronomical question, and that involves only, or primarily, lunar crescent visibility. And hey, I'm the world's expert on that. I am doing, how I'm approaching that problem is how a classical modern astronomer would approach it. And, so I've got a gazillion equations describing everything.
Because what you're looking for is not when the new moon occurred, but when people could see that the new moon occurred.
Exactly. Yes. And that's a difficult astronomical problem. I've also approached that by quite a lot by collecting and making observations of real visibility of the thin crescent moon. I've collected large numbers of, moon watches where we'll get 1,000 people spread around America, and each one will say whether or not they could see the moon. And you can make a map, and you can draw probability lines on the map of where you can see it and not. So I've done a lot of checking and testing of these things. So I have a much better model of predicting lunar crescent visibility, and you can then go applying that to this task of Friday, the 14th or 15th of Nisan, 27 to 36 AD. Okay, fine.
So you've obviously come up with the perfect certain answer that everybody should believe, right?
Actually, yes, but it doesn't help much. There are a couple of reasons why it doesn't help much. Well, first off, it turns out the answer I have turns out to be identical to the answer largely has been coming up in history. In other words, even if I have a sharper tool, doesn't mean I'm not going to get the same answer. Okay, fair enough. So the long historically, the answer has always been there are two possible dates, one in the year 30 AD, one in the year 33 AD, both in April. And so there are two candidate dates. And usually in the past, people select one or the other on pretty weak reasons. That's fine. And then they select one and then declare they found it. But the reasons for choosing from one to the other have always been very weak. And so I'm at least coming out and acknowledging that, the answer is ambiguous. We don't know which of the two possible dates. And so let's see, the two possible dates are AD third, in the year AD 30, April 7th, also in the year 33 AD, April 3rd. So there are two possible dates, and you can make arguments back and forth to try and decide between them, and you can convince your parents, but nobody else, or
which actually
try to convince your parents.
Brings up the fundamental question behind it. With all the research you've done, how many hours after the actual new moon can one expect to be able to see the crescent?
If it's older, if the moon is more than 24 hours after the time of conjunction, new moon, you got a pretty good chance of seeing it. It's been a game. I and many of amateur astronomers have played, for me, since high school and actually junior high school, of trying to spot the youngest crescent moon. And I think my youngest is something like 17 hours. But I here in Tucson, I go out with a guy named Jim Stam, who has the world's record for seeing the youngest crescent moon. And he's all the time trying to find things. So the youngest crescent moon you can see with the unaided eye is about 14 hours. And there are going to be months when you might have a hard time seeing it when it's 30, 40 hours old.
What are some of the variables that make the difference?
A time of year, because in springtime, the ecliptic has a larger angle with respect to the horizon. So for a given time after sunset, the moon is lower into the haze and you can't really see it, and it sets sooner. That's probably the most prominent variable. The other one is simply how I would call it the extinction coefficient, or how hazy the air is, because you're looking down low on the horizon, and so you're always looking through 20 air masses of haze. And so if it gets a little bit hazier from a given site, then you're looking through a lot more and it's invisible. So there's a huge difference between John's site in Baton Rouge and me here at a higher altitude in Tucson right now. So that sort of stuff makes all the difference in the world.
Other questions here before we launch into the second topic I wanted to bring up with Brad. Feel free to anytime type them in the chat, and I'm keeping an eye on them there. But one of the cool things you can do with this visibility of the moon, I will skip over the entire question of the Muslim calendar and when does Ramadan begin and when does Ramadan end.
Happy Ramadan. We're in the middle of Ramadan right now.
Right. And I know there's great arguments as to, can we finish fasting or not, depending on whether you've seen the moon. But one of the other cool things that I remember you asking me, it was before the 2017 eclipses, there was a song we grew up with, "On a clear day you can see forever." In fact, on a clear day, which is to say when the sun is above the horizon, what's the most distant object that the human naked eye can see? And how
That's quite a change in topics, but again, that feeds back into my specialty of what the human eye can and can't see. Martha and I were on a vacation resort island in Heron Island, and at nighttime there was a little dumb trivia contest, no big deal, no nothing, and that was the question that the trivia person asked, and I gave the correct answer, and he counted us down because he was expecting 93 million miles so you could see the sun, and couldn't argue him out of it. And the guy was wrong. And because of that one lost question, we lost the trivia match. I've never forgiven him for that. So kind of the correct answer is 93 million miles. However, it's really easy to see Venus in the daytime. Venus, when it's a little bit further away than 1 AU, it's bright. Anyone can see it if you know where to look. And so you can get out to like 1.7 or well, more like 1.4 AU that way. But there are other people who can see Sirius during the daytime. It's hard. You got to know what you're doing. You have to have perfect conditions, but you can do it. And there are a reasonable number of historical reports. I've been able to see that myself. There you go. Okay. I've also, this is kind of a weird thing. In an effort to answer the question of whether you could go down to see Canopus. Canopus is the second brightest star in the sky. Well, can you push past Sirius to catch Canopus? Well, Canopus is in the far south. So I needed a location in the southern hemisphere, presumably around latitude minus 33, or was it 31 degrees? So Canopus was right overhead. I needed a high altitude because you get best extinction coefficient site then. You need the highest altitude possible. And you needed a really clear, dry site. You'd think Chile might be optimal. Okay. Another trick you can play is if you are high up and the sun is low down, you can get a few more minutes of daytime by the horizon dip, and the sun will set a little bit later than if you were at ocean height. So you get a few more minutes and the sky gets that much darker. So you wanted a high altitude Chilean site, okay? And so what I did was I put in a formal out and out proposal to Ceratololo Observatory. And I'm sure this is the only such proposal they've ever bloody got. So I put in for telescope, well, actually it was naked eye observing time on Ceratololo. My proposal got accepted. And
you weren't competing for other people's naked eyes.
Yes, I got my time. And I was actually, by playing all the various tricks I know how to play, I was able to see Canopus with the unaided eye in the middle of the day, or not in the middle, during daytime. There's another exception you can think of, and that is, why don't you look during an eclipse? Okay. Okay, so looking back in history, there are a lot of reports of seeing stars. The sky is full of stars, you know, not just from 2001, but the actual reports of seeing stars up in the sky. And now what I've been doing with most of my eclipse totality time in the past 6 eclipses, not this last one, is I've been looking for stars with the unaided eye in the middle of the daytime. And most of the time, what I find is the only stars anyone's likely to see are the planets. You might see Sirius if it happens to be up, but you have to look hard for it. You have to know what you're doing. And the average layperson isn't going to do this. So those old historical reports probably are just this, the sky wasn't filled with stars. It was, the sky was filled with a couple planets. Okay, that's fine. But here's something I did randomly. This is during the eclipse in Aruba. Actually, I was the paid lecturer for one of the Sky and Telescope expeditions. They actually even paid Martha's and my way to Aruba. Great vacation. Okay, so in Aruba, I used all my time of totality to play all the tricks I know how to play. And I was able to see with my unaided eye Deneb, Alpha Cygnus. It's one of the faintest of the first magnitude stars. And I chose Deneb because it's also one of the most luminous of the first magnitude stars, and hence the farthest. And so I would claim, dubious though the honor of this is, I have seen the farthest of anyone in the daytime.
Since we're bringing up eclipses and we're all excited about it, how many total eclipses have you tried to see, and how many have you succeeded in seeing?
I have, I think this will be the 8th, number 8, and I've been clouded out in only one. Oh, wow. It was a horrifying clouded out one. It's another one of these paid vacations for Martha and me at Sky and Telescope to going to Hawaii. And in Hawaii, I was kind of constrained by having to be with our group. I was constrained to the grounds we had on the Kona coast, and couldn't. I did not think I could go moving. And there was this one blasted cloud that just stayed there, and it stayed there, and it stayed there. And if we'd gone down the road 10 miles, would have had a perfect sight. And so that is when I decided to not do these gigs anymore, because that way I can be mobile and so on.
Well, of all the times, I mean, I've managed to see exactly one.
Which one?
I've been, rained out a few times. Everybody here is pretty experienced astronomers. A number of us have seen total eclipses before. In your experience, what are some of the cool things to look for that not everybody would think to look for?
Yeah. One thing one should emphasize is, hey, just sitting back and using your 4 minutes of totality to grok the whole situation, that's worthy. You can watch the incoming shadows sweeping across the sky. There's weird coloration around the edges. And it just is actually, I'm getting hairs rising on the back of my neck here. You people who say that you're going to be in partial phases, all partial phases are fun and good, but there's just something about totality that'll make it one of the best experiences or best things of your life. And partial phases are 12th best, and totality is wow. And I think actually a part of the reason for that is because humans are kind of hardwired to this. Religiously, or at least in ancient times, all ancient religions, or most anyway, key off of the sun is one of the primary gods in the pantheon. And an eclipse of the sun, that can only be viewed as the death of a god, and that is not good. And so all cultures everywhere have always taken solar eclipses and lunar eclipses as being among the worst, most evil omens in the sky. Because what's happening here is that if you get a sign, an omen in the sky, only the gods can place it up there. And there has to be, they're trying to tell you something, and it's usually pretty bad. And that's, well, maybe too high of a philosophical thing, but it means we all, when you see a total solar, it's just, woo. There you go. And anyway, back to what you can see. Just sit back and enjoy the situation. Watch the cloud. Watch the shadow cones sweeping over you and the weird color effects going on around. Take a quick peek at the animals nearby. See what they're doing. Animals often behave weirdly. Another thing you can try doing is before and after totality for about 5 minutes, you can go looking for the weird shadow bands. And that's something that doesn't take up time during totality. And it's something you can do that's kind of one of these weird things. A shadow band appears when you look on the ground, hopefully a smooth white ground. You can see these weird faint bands along the ground, and they're moving, they're running, they're passing forward. And it's just a weird thing you're never going to see any other time.
What causes that?
I would advocate, well.
What causes that?
Basically, it's twinkling. It's twinkling of a correlated long straight line. And the bands are caused by the visible sun being mostly a long thin line, and the movement is caused by the twinkling air rushing by in one direction or another.
So I've got one question here. You know, you're talking about your eyesight, and I noticed you're not wearing glasses. Have your eyes been fine-tuned with cataract surgery or anything else like that?
I've been lucky.
Also, Kelly adds the comment, which I think is marvelous. She quotes Annie Dillard, who says, seeing a partial eclipse bears the same relationship to seeing a total eclipse as kissing a man does to marrying him. To which Tom replies, I know a lot of people who wish they had stayed with the partial eclipse, but we'll go beyond that.
That would be the Ann Dillard who taught for a long time at Wellesley. Wellesley.
Yeah, Annie Dillard, she has that famous 1980 essay. It's called Total Eclipse. If you haven't read it, it's one of the best contemporary literature pieces on what it's like to actually experience totality. She talks about seeing the shadows running over the hills for miles coming up, and it's incredible. I think you can Google it. I'll see if I can find a free link and drop it in the chat.
Sure. I had my first astrophysics class from her out at Wellesley.
Somebody asks, are there any of these shadow effects that you will see during a partial eclipse?
Nah, not at all. You won't see the shadow bands sweeping in. You won't see the weird animal phenomena. You won't see the weird things of the people around you. I'm a yeller, and many people are, and how you behave during an eclipse is a deep insight into your personality. Maybe.
We can come back, but there's one other topic I wanted to bring up before we run out of time, and we've got down to about our last 10 minutes. And this is a topic that has had you in the news the last week or so. I've seen you quoted. Somebody saw this goofy thing. I said, who said that? Oh, some professor from Louisiana State. What do they know? I go, oh, I think I know that guy. But I'll start it out by describing when I was in graduate school in Arizona, sharing in a house with a guy named Bob Howell, who was, another astronomer. And middle of the night, he's, about 11 at night, he shows up at our apartment having ridden his bike from school, saying, you've got to come out and see this. I nearly fell off my bike while I was riding home because I was looking at the stars. I'm going, it's at night, you're on a bicycle. Why are you looking at the sky? But of course, we do that. And he had seen a star in the sky that shouldn't be there.
Cygnus,
it was a naked
1975.
eye nova.
Yeah, it was 1975's Nova Cygni.
Yep, and that was exactly what he had seen, which I had seen. Well, it's hard to predict when these novas are going to come, but there's this crazy professor from Louisiana who thinks he can do it. Tell us about that.
Sure. Well, this isn't anything special for me because, what the heck, back in high school, I had already predicted that I and many other people had already predicted that this particular recurrent nova, T Corona Borealis, T Corbor, was going to go up around about now. If back as a high schooler, I already knew that, well, there you go. Everyone knows it's going to go up anytime now. Historically, T Corbor is one of the most famous of all the nova. It was the first nova that was kind of even really observed at all, and many other things like that. It went off in 1866. It went off again in 1946, and it's going to go off in the next couple months. It could go off tonight. The best estimate date is for April or May of this year, or probably by the end of summer, and even more probably by the end of the year. So sometime in the upcoming months, maybe tonight, T Corbor is going to go up. When T Corbor goes up, it should, all recurrent nova always come to the same peak brightness as every time they go up. And so we know how bright T Corbor got when it went up previously. Actually, I have recently come across an old Russian IAU or an old IAU circular that came from a Russian that reported the very, very first observation of the 1946 eruption, and he quoted the thing as being 1.7 magnitude. So presumably when it goes up again, it's going to be at 1.7 magnitude, almost first magnitude.
And then how long does it stay that bright or naked eye?
Not much.
A day, 2 days, a week?
It rises from nothing, or its current quiescent level. It rises from that to peak probably in a couple hours. And it stays at peak brightness for a few hours, maybe half a day, depends on how far you're willing to call the peak. And then it fades away fast. So it's completely out of naked eye visibility after 7 days. So you got 7 days for the naked eye to see it, and you only got a night or two to catch it when it's near peak. But if you look at the right time and you know where to look, all of us can go out and pick it out. You probably could even see it from downtown New York. Well, it would help to have binos and know where to look, and you probably should wander around to a dark part of the city. But the point is, all of us can walk outside and see it if you know where and when to look.
And anybody who's trying to figure out where Corona Borealis is, if you know where Arcturus is, which you can find from the Big Dipper, you arc to Arcturus by following the curve of the handle, and you know where the summer triangle is, Corona Borealis is roughly in between Vega and Arcturus.
Right.
Not quite halfway.
It would probably help substantially. If you're not familiar with the sky, it would help substantially to have some sort of a chart. The Sky and Telescope web pages have that, and that'll be appropriate for the time of year, and that'll show you where to go from Arcturus down or up from Hercules or something like that. So it would be best to have a chart on this. There's a little bit of an ecclesiastical connection for T Corbor. Here's kind of a weird thing that I've done recently. I've found a prior eruption of T Corbor, not this time, not 80 years ago, not the years before that. But if you keep going back in time, you expect to have T Corbor been going off and being the brightest nova of our generation of generations, and you expect it to have happened once every 80 or 79 years or something like that, going back through human history. So you can and should and go back and look for historical discoveries of T Corbor. And I found one. It's from the year 1217 AD. You got to say AD. We're not really getting that far back. 1217 AD. And I found it in a monastic annals, the usual monastic annals where they highlight the top couple events of the year. And there is a very clear and provable observation of the nova Ticor Bor in autumn, October, specifically, October of the year 1217. And the observers, well, this report appeared in the Erzberg Chronicles of the Erzberg Monastery near Augsburg, Germany. And the writer was, he says he was an eyewitness of this. And the writer was Abbot Burchard, who was one of the more learned men of the time in Europe. And so we have Abbot Burchard going out with his monks and seeing this weird thing in the sky. And the phrase he used for it in Latin was signum mirabile, or wondrous sign, or miraculous sign. The only other time I've been able to see him use that phrase in the Chronicles is when he's referring to biblical miracles. Yeah, there you go. So he's clearly taking this as a sign from God. After all, it's up in the heavens. Who else could be the author of an omen up there? And
what do we think
here we have a nova being taken as being a very positive sign.
Cool. What do we think actually causes this particular kind of nova? I mean, there are lots of novae and they have a lot of different causes. What's the root cause of this one?
Oh, well, they're all the same. All the nova are the same. Briefly, you have an ordinary binary star, no big deal. Except one of the stars is an ordinary star. Another star is a collapsed star, a white dwarf. And the binary is sufficiently close in orbit that mass can fall off, literally fall off of the ordinary star and fall onto the white dwarf. When it falls onto the white dwarf, the hydrogen-rich material accumulates and accumulates and accumulates, and sooner or later it's going to reach a temperature which is the kindling point of hydrogen. The hydrogen starts burning. This is nuclear burning, and once that happens, you have a runaway explosion, and you're seeing the expanding shell expanding around it. What it is, it's a hydrogen bomb. It's an H bomb, just like in the movie Oppenheimer. Instead of the super, it's a nova.
Well, the question then is, what causes some to have longer periods or shorter periods?
Right. To get an 80-year recurrence cycle, like what Ticor Bor has, you need two things, and both are needed. You have to have a white dwarf mass, which is very up near the upper limit of what's possible. We call it the Chandrasekhar mass. It's got to be real close up there. Another thing is the system has to have a very high accretion rate. You have to have a lot of matter falling off of the ordinary star, falling onto the white dwarf, and it's got to go fast. And those are the two requirements to get a short recurrence timescale like Ticor Bor has.
What are some of the other short period novas that we know?
For short recurrence timescales, we only know 10 recurrent nova in our own galaxy. We know comparable numbers in other galaxies. There are only 10 in our own galaxy. So this is a rare system, because you have the two requirements and you have to have them both. And it turns out each one of them is uncommon. And so you square that and you get a rare phenomena.
What do we learn from knowing this besides the fact that, oh, that's cool?
Well, that's adequate, actually.
I can't argue that.
Seeing a nova, going out, walking outside and looking up and seeing this titanic cataclysm. Actually, I can use this word because it's a compound word. I saw it this morning in the Scientific American post. You go outside, you look up, and you see hellfire. Yeah, wow. And it'll just be up there. You can see it.
I would imagine that this also does give you a way of confirming the Chandrasekhar limit.
No, that's not going to help that at all. There are a variety of unique features of the Ticor Bor eruptions, which is where I'm trying to get answers to. And there are things that Ticor Bor does that are subtle for people like me, but they're weird and they're totally unique. And me and many others are trying to work out what on earth is going on with them. But probably the biggest question here is T-Core has long been identified as being one of the best, I don't think so, one of the best candidates for being a progenitor for a type 1a supernova. Okay, type 1a supernova, big deal. That's when the white dwarf is fed matter and it goes over the Chandrasekhar mass limit and explodes the type 1a supernova. These are the ones that you use to discover dark energy and things like that. Fine. But there's been well, actually, since we met, geez, there's been long controversy as to exactly what is the progenitor, what type of star system makes these type 1a supernova. We know a lot of the details, but the general setting we're arguing back and forth all about. Now, in the case of T-Core, I think I know what the answer is. And the answer is T-Core cannot become a type 1a supernova because it's a neon nova. And I know that only because some observers in France back in 1946 observed late in the tail, they observed some neon lines in the spectrum. Okay, but anyway, we're playing into this large game of whether T-Core or a recurrent nova can become the type 1a progenitor. The type 1a progenitor problem is one of these grand challenges. It's one of the biggest in astronomy, in astrophysics. And we're playing in that game here of trying to understand T-Core and the recurrent novae.
So that in essence sort of answers what Richard Somm's question was, does this contribute in any way to our understanding of the distance ladder? And presumably not directly, but in helping to understand the supernova, it does.
Right. But probably the best answer is just, hey, it's neat and it's cool. You know, it's kind of like Babe Ruth pointing to a part in the thing and then batting a homer to that position. Here we're doing kind of the, who would have thought it's possible? We're saying there's going to be a nova in the upcoming months, and it's right there.
And you'll be able to see it with the naked eye.
Yeah, and so that's probably the best answer is, it just would be weird and fun and evocative and if you're like Albert Burchard in near Augsburg, Germany, you would say, wow, this is a wonderful sign.
Okay, well, this comes to the close. I think this is a great place to close. Thanks a whole lot for joining us. Thanks for reminding us that naked eyes can actually be used for cutting edge astronomy, and also that naked eyes can be used to remind us why we do the astronomy. The joy and the gosh wow that just comes from seeing the sky.
In the Psalms, it says, and let the heavens declare the glory of God. And that might be the best thing to close with.
Thanks a whole lot for coming. See you guys all next full moon.
Thank you so much.
Bye, Brad.
Hey, bye, John.
Yep. Wish you had been here for Alcon.
Couldn't make it.
Yep. Okay. Craig has now moved to St. Louis.
Okay.
Yep. So
obviously to be in near the path of totality.
Actually, no. His wife wanted to move because the kids are there.
All right. I've actually got another thing I have to get off to, so I'm going to abandon you now.
All right, brother. I'll see you in about an hour.
Okay. Take care.
Okay, anyway,
Bye-bye,
just
guys.
want to give you that update, Brad, and stuff. So
yeah.
hope to see you sometime.
This was exactly what we were looking for. Thank you very much.
Bye, Brad.
Thank you. Thank you so much, Brad. Your enthusiasm was entirely contagious.